Okay, the exercise for F, we 1A, we have solve it. So let's look at 1B. The integral x squared y dx, the line integral x squared, okay, y dx plus x dy, okay, plus x dy, where the C is the closed triangular path from origin to 1, 0, 1, 2, and back to the origin in that order. Okay. Exercise 4F, questions 1B. The line integral x squared y dx plus x dy along the curve C. C is a closed triangular path from 1, 0, 1, 2, from origin, so 0, 0. So it's a triangular path. So you draw the that circle to C. From origin here, 0, 0. And then 1, 0, x is 1, 1, 0, y is 1, x is x is 1, y is 0. Yeah, 1, 0. And then 1 to 2. Let's say here 1, 2. So you got C1, you have C2. And then they said closed triangular path from origin to 1, 0, 1, 2, and back to the origin. So you got C3. So the questions is verify Green's theorem. Verify Green's theorem, then you have to do both hand side. Verify. Green's theorem. So first of all, Green's theorem, you got mean the double integral here, the line integral equal to mean the line integral m dx plus n dy along the curve C will be equal to the double integral del n del x minus del m del y. Is it correct? dA. Is it okay? So it's del n del x minus del m del y dA. So verify Green's theorem, then you have to do the line integral. So along C1, C2, C3, and also the line integral, which is a double integral, del n del x minus del m del y, dA over region R. So first of all, we do the line integral. So you got curve C1, C2, C3. So the line integral along curve C, you have to break it into C1, C2, C3. So let's say C1, we look at the C1 first. C1, C1 on x-axis, x-axis. So y equal to 0. That's why you let x equal to t. X is from 0 to 1. That's why t from 0 to 1. So you from x, y equal to 0, then dy is 0. X equal to t, dx equal to dt. So plug in into along so the line integral along curve C, you have to do on C1, C2, C3. So 3 result add up together. So replace x by t. So x squared will be t squared y is 0. Okay, and then dx is dt. First term, because y 0, first term gone. Okay, and then plus x is t dy, okay, 0. Okay, that's why, the line integral along the curve C1, you get the answer is 0. Where is it? Okay, and then along the curve C1, because y0, dy 0, so the line integral along curve C1, answer is 0. And then you do for curve C2. Okay, C2, you see, constant is x equal to 1, right? So you got x equal to 1. Okay, and then y, move from 0 to t. That's why let y equal to t, where the t is actually equal to y, move from 0 to 2. Then you find the dx will be 0, dy equal to dt. So plug in, the parametric equation into the line integral here. So the line integral along curve C2, x is 1. So x is 1, y is t. So you got t. Dx, you have 0. So first term still 0 because dx 0. Okay, and then x is 1, dy is dt. Okay, integrate t from 0 to 2. You got from 0 to 2. So integrate 1 dt, you have t from 0 to 2, the answer is 2. So the line integral along curve C2, you get the answer is 2. Correct, I will check. Dx 0, first term 0, x is 1, dy is dt. So integrate 1 dt from 0 to 2. Okay, you got answer is 2. Then you do on line C3, curve C3. Okay, curve C3, you can either using, either you can obtain the linear graph. So you see, this one on curve C3, look at here. Okay, you can have y equal to mx plus c. M is the slope of this linear graph, where is actually 2 over 1. Y, the vertical is 2 unit, horizontal is 1 unit. So the slope is 2. So that's why you have y equal to c is y-intercept, which is 0. That's why you have y equal to 2x. Okay, then you can let x equal to t, y will be 2t. Okay, and then x move from 1 to 0. That's why t is move from 1 to 0. 1 to 0. Because here, x move from 1 to 0, so t, because x equal to t, so t move from 1 to 0. Okay, so you plug in this information to the line integral. Okay, C3 along x squared dy, x squared y dx squared y dx plus x dy along curve C3, t from 1 to 0. Okay, x is t, so x squared, you got t squared. Okay, y is 2t, y is 2t. Okay, and then you need to find dx will be equal to dt. Okay, x is t, dy will be 2 dt. So you got dy is 2 dt. Okay, 1 to 0. So 2t cubed, you got 2 t cube. This is 2t, okay, total dt. So you can either directly using your scientific calculator, or you want to integrate it manually. So 2t power 4 divided by 4 plus 2t squared divided by 2, 1 to 0. Okay, when plug in 0, okay, everything 0. Plug in 1, you have half. Okay, 1, okay, half. So this one, plug in 1, you have 1. So 1 plus half, okay. So minus 3 over 2. Okay. So the line integral, because you got C1, C2, C3. So C x squared y dx plus x dy. Okay, you have to add up the C1. Okay, add up the C2. Add up the C3. Okay, C1 we obtain 0. C2 we obtain 2. 2. C3 is negative 3 over 2. So the answer we obtain here is half. Okay. Question 1b. Okay, answer is half, correct. So this is the left side of the line integral, left side. Then verify Green's theorem. So now, we'll solve using Green's theorem. And the x squared y dx plus x dy. Okay, using Green's theorem. Okay, del n del x minus del m del y dA over region R. Okay, where this is m, this is n. So equal to, you del x, okay, coefficient of dy, which is labeled as n. So del x minus, okay, del y, coefficient for dx, which is labeled as m. So x squared y dA. Then you do the partial derivative first. So delta x, you have 1. Delta y, x squared y, you have, okay, x squared. Okay, dA over region R. Okay, region R, look back, okay, the region R that we sketched just now. Okay, curve C1, C2, C3. So the region R is inside here. So we can solve it using dy dx. Okay, the vertical bar touch x-axis, which is y equal to 0, and the linear graph just we already obtained, which is y equal to 2x. Okay, this linear graph. So the you use dy dx where y 0 until 2x. Okay, and then you sum the vertical bar from the leftmost point, which is x0, until the rightmost point, which is x equal to 1. Okay, so equal to x equal to 0 until x equal to 1. Then y equal to 0 until y equal to 2x. So 1 minus x squared dy dx. Okay, so I can simplify 0, 1. Okay, integrate respect to y. 1 minus x squared is constant. So we have, actually, this is y, the constant. Okay, can remain, okay, outside to dx. So y from 0 to 2x. So you got 2x, and then 1 minus x squared dx. Okay, you may directly use scientific calculator at this step, or you want to integrate it manually. Then you expand, okay, manually. is 2x minus 2x cubed dx. Okay, so you get, okay, x squared divide by 2, 2 and 2 cancel, so it's just left x squared. So minus, you got 2x cubed divide by 2x power 4, sorry. 2x power 4 divide by 4. 0 to 1. Okay, simplify it. So the answer you got, so 1 minus half. Okay, plug in lower limit, everything 0, so the answer is half. So by using Green's theorem, we obtain half by using the line integral. Okay, you have to do it along curve C1, the answer is 0. Along curve C2, answer is 2. Along curve C3, answer is, okay, negative 3 over 2. So add up, we have half. So, okay, so we have verified, okay, this question using Green's theorem. Both give the same answer, which is half. Okay. So